In this short video, I'm going to introduce numerical methods. We have learned how to solve equation. For example, solve quadratic equation x squared minus 1 equals to 0. So we plus 1 both sides. We have x equals to plus and minus 1. Solve the equation that involve let's say ln x equals to 1. So what is x? We can take anti-log. So x is equal to e raised to power 1, which is equals to e. This type of equation can be solved by using the normal method. For example, you might factorize it, you might use quadratic formula for quadratic equation. Then for this equation, you might use anti-log to get the x. But for some equations, they cannot be solved by this way. For example, how to solve ln x minus x equals to 0. What is the values of this x? So that ln x minus x equals to 0. If you try to solve it, let's say you make x a subject, and then you take anti-log, you get ex equals to x. Somehow it still cannot be solved. One more example. Let's say x equals to cos x. How to solve this equation? Can we factorize the x and cos x? It cannot be factorized. So this equation cannot be solved. But somehow we can obtain an approximation. We can obtain approximation answer for this x. So in this chapter, we are going to learn to find the roots of this equation. Find the roots of this equation approximately. There are few methods. First, through graph. Second method, we search for changing of sign. And the third method, we can use Newton-Raphson method to find the approximate root for those equations that cannot be solved directly. Let us start with graphical method. Example 1. By using graphical method, show that the equation ln x plus 2 minus x is equal to 0 has a positive and a negative roots. Before we do anything, we make x as subject is equal to ln x plus 2. Equal in geometric aspect, it means the intersection point between two graphs. The first one is a linear graph, y equals to x on the left hand side, and the second one is a curve, y equals to ln x plus 2. Now we are going to we are going to draw by using proper scale for x and y, as is not sketched. Then we attempt to find the intersection between these two graphs. Let's start with y equals to ln x plus 2. Let's revise back how to sketch ln graph. First, Set the domain. X plus 2 must always a positive number. X greater than negative 2. That means for this graph, we have a vertical asymptote. Now we are going to draw this graph. So draw, use ruler. You can set 1 cm as 1 unit. So y-axis, x-axis, -1, -2. This is a vertical asymptote. This is -1. We might get few points to draw the graph. So plot few points. X equals. So when x is, we can substitute few values of x. Let us start with -1.9. So ln -1.9 plus 2 is 0.1. You can check the values from calculator. Then we might try -1. -1. Ln -1 plus 2 is 1, which is 0. Then x0. x0. Ln 0 plus 2 is ln 2. And then we might try when x is 3. So ln 3 plus 2 is 5. Let's check each point. So for ln 5 is equals to 1.6. How about ln 2? Ln 2 is equal to 0.7. How about ln 0.1? 0.1 is equals to -2.3. Now we can plot these points. I will use the green color. So -1.9, -2.3. Let's say this is -3, -2.3, -1, 0, 0. This is 1, 2, 3. 0 is 0.7, and then 3 is 1.6. 1.6. So draw a smooth curve passes through this point. Passes through this point. Okay, this is a long graph. Next, we draw the linear graph x, y. So we might get few points when x 0, y also 0. So 0, 0. X -1, y also -1. And then x2, y also 2. So 2, 2. Draw a straight line passes through this point. Okay. So from what we have drawn, we obtain a positive root. This is the positive root. And another roots, negative roots. This is the negative roots. This is a negative root. That's how we show that this equation has a positive and a negative roots.